This is Chapter 3, Displaying and Summarizing Quantitative Data Part 4, Mean and Standard Deviation. So we talked earlier about the median, and the median being a measure of center. Well, the mean is also a measure of center. Now, for a data set that shows strong skewness or outliers, then the median is going to be the better measurement for describing the center. If the data is unimodal, somewhat symmetric, then the mean and the median should be about the same, and either is a reasonable way to summarize the center of the data. You just want to be careful if you're working with a data set that has outliers or it is skewed, because the mean is not going to be the best representation of the center. The median is going to be your better measure of center in that circumstance. Now, the variable for the mean is y bar. And we have this notation sigma, that just means the sum. And then if you remember from before, n is the number of observations in our data set. So the calculation for the mean is we sum up all of the values in our data set, and then we divide by the number of observations in the data set. So the mean or the median, I mentioned this on the previous slide, but I'm going to touch on it again. The median is less influenced by skewness or outliers than the mean. That's why the median is the better choice for measuring center if you have that type of data set. The mean looks at all of the data points, and it is sensitive to outliers and skewed distributions, so that's why your mean is not going to be the best measure if you're looking at a skewed data set. You're better off going with the median. But once again, if you have a data set that is approximately symmetric, and once again, I say approximately symmetric, it doesn't have to be exactly symmetric, but as long as it's approximately symmetric, then you can use mean or median in that case. Something to keep in mind, if you're looking at values for mean and median, okay, if the mean is greater than the median, then your data set's going to be skewed to the right. If your mean is less than the median, then your data set's going to be skewed to the left. When we talked about median, we used the interquartile range, or the IQR, to measure our spread. For the mean, we're going to use a standard deviation to measure our spread. And just like the mean, standard deviation is most appropriate when the data is approximately symmetric. Now, we use a lowercase s as our notation for the standard deviation. And we've got this pretty lengthy formula here for how to calculate the standard deviation, so let's just walk through it. So the first thing that you're going to do is you're going to calculate the mean of your data set. Once you have that number, you're going to subtract the mean from each data point. Okay, so individually you'll go down and you'll subtract it. Then you're going to square each of those deviations. Okay, you'll take all of those values and you're going to sum them up. So you're going to sum the squared deviations. You'll divide that number by n minus 1. Take the square root of that value, and that result is going to give you the standard deviation of the data set. So let's walk through an example of how to calculate a standard deviation. So I broke this into a table of columns so it's easy to follow. So the column to the left, those are all of our individual data points. Okay, those should look familiar because that was the same data set that we used when we were looking at the median and calculating our box plot. So we have all of our data points there in that left column. Okay, so in the second column, that is our mean, that's our y bar, and it's 16.2. So we have a 16.2 in all of those cells. Then the next thing that we do is we're going to subtract our mean from our data value. So 2 minus 16.2 will give us a negative 14.2. 3 minus 16.2 gives us a negative 13.2, and so forth. Okay. Now we take the values in that column and we're going to square them. That's our column on the far right, our fourth column. So negative 14.2 squared is 201.64. Okay, so we're going to do that for all of the values. And then we want to sum that column. Okay, that gives us the sum of our squared deviations, and that value is 2305.6. Okay, so our data set has 10 data values in it. So our 10 minus 1 is 9, or our n minus 1 there is the 9. And so what we do is we're going to take our 2305.6, divide that by 9, and then we're going to take the square root of that, and that gives us a standard deviation of 16.01. So this is going to wrap up our chapter 3, displaying and summarizing quantitative data. So let's kind of do a quick little review, a little summary slide here. So we're going to make a histogram, a dot plot, or a stem and leaf display and discuss the shape of the distribution. Okay. Then we want to discuss the center and the spread. One thing I want to emphasize is never report the center without reporting the spread. And I see this so many times. I see people report the average value of something. Well, having the average value alone is really not a lot of information, and you should be reporting the spread. Okay. Now, what spread do you report? If you're using a median, you always want to use the IQR as your spread. Okay. Median and IQR always go together. If you're using a mean, then you want to use the standard deviation. Mean and standard deviation always go together. Okay, you can't mix and match there. Median, IQR, mean, standard deviation, always. If the distribution is skewed, report the median and the IQR. Don't use the mean, because the mean is going to be less valuable if you've got a skewed data set. If the data is approximately symmetric, then report the mean and the standard deviation. If you want to, you can also report the median and the IQR. Okay, but if it's approximately symmetric, you're fine with the mean and standard deviation. Okay. Next is you want to discuss features like multiple modes and why they exist, and outliers and why they exist. Remember, we talked earlier about outliers can be very interesting to look at. So you want to make sure that if you've got an outlier, make sure it's not an error. If it's an error, fix it. If it's not an error, then it's going to deserve some special attention.